So I want to talk to you about how to make this evolving of an architecture real that Randy referred to in his opening keynote. Because we've actually gotten pretty good at dealing with business requirement changes, at least theoretically. In practice, in some places, not so much. But at least we kind of understand what it takes to make something like that happen. But what we haven't necessarily gotten our hands around yet is, what about this ecosystem change stuff? We also alluded to this. The frameworks are changing. The languages are changing. It used to be, when I started back a long time ago, you never persisted anything unless it went into a relational database, because everything had to be in a relational database. It didn't matter if it wasn't relational data. And now we have these things called graph databases and key value pair stores and all of these new things. And so we have technological capabilities that were perhaps possible, but not easy to do with the tools that we had available in the past. And when I think about what the job of an architect is, it's really this long-term thinking, this how do I maintain and nurture and increase the enterprise value of the IT estate. Now, the bulk of my experience, particularly with ThoughtWorks, was working with very large enterprises. But I've worked in scientific computing, I've worked for startups, I've pretty much run the gamut of the different kinds of systems that you could deal with. But in an enterprise context, somebody has got to worry about those costs that were mentioned. Who's going to think about the licensing for Kafka, and was that really the right choice to make? But how is this long-term planning possible when all of that stuff is changing beneath you? It used to be, again, when I started, when you could have a 5 or 10-year architectural roadmap. That was actually possible. We can't do that anymore. So the role of an architect, while still necessary, is very different than it was back in the mainframe days. In fact, when I was studying in graduate school, architecture didn't mean anything like what we're talking about here. It was the architecture of the computer chip. That was what they called architecture. They never talked about any of the things that we worry about today. And so I want to go into a bit more detail about what does it mean to be an evolutionary architecture. And I first want to talk about the name. I loved that you brought up why emergent architecture is a problem. Because the first time I heard Neil Ford speak about this topic, he was calling it emergent architecture. And he and I had a very robust discussion about why that was a really bad idea. Because what does that mean? It just kind of happens. And that might work for emergent design. When we think about refactoring, when we think about starting very simple and how we're going to make the code changes and the design is going to emerge, that's actually not a bad metaphor. Because there really is a definition of good code and bad code within a language context. Doesn't matter if it's a retail system, doesn't matter if it's a banking system, doesn't matter if it's a weather simulation. You and I will probably be able to all look at the same piece of code and say, really good, okay, ugh. That's not true for architecture. One of the projects I worked on was a trading system. Now, you all are thinking, trading system, high throughput, low latency, gotta move, gotta move, gotta move. 100 transactions a day, tops. They didn't care about performance. They cared about never, ever losing a message. There is no such thing as the perfect architecture. It doesn't exist. Because what's important, what matters, varies from system to system, even from enterprise to enterprise. I dealt with one company And they really wanted a distributed architecture, except they didn't. Because every time we presented a distributed architecture to them, they said, but what happens if we lose Italy? What do you mean, lose Italy? I'm making up the country, by the way, but the rest of that sentence was a direct quote. They had had a catastrophic failure in their past when they lost communication to all of their entities in a whole country. And so even though they really wanted a distributed architecture, the organization was pathologically afraid of not being able to talk to their stores. So we ended up with this really strange hybrid distributed centralized architecture to support what they wanted and what they could accept organizationally. So it's really important to get the name right. This isn't an emergent architecture. This isn't an adaptable architecture because we can't predict where to put the adapters. This isn't even just an agile architecture because it doesn't get at that key observation, which is not every architecture is right for a given situation. So here's our definition. An evolutionary architecture supports a guided, incremental change across multiple dimensions. And it's this word guided which helps get at this. What is the kind of design you need to do up front? Part of it is you identify what are the critical architectural characteristics. That's our word for what you were talking about in terms of behaviors. Architectural characteristic, what are the ones that are going to determine the success of your architecture? For some, it will be security. For some, it will be uptime. For some, it will be throughput. For some, it will be one of those many other abilities. Your first job is to decide what is important. Many of the metaphors that we use as well are more biological and also from physics. But this is, I got the original idea for this nomenclature. I used to work in genetic algorithms. And in many forms of function optimization, you have a fitness function that says this is what good is. And so we stole that notion of a fitness function to talk about architectural characteristics. So in an evolutionary context, traveling salesman person problem, the length of the route. This might be percentage uptime. This might be throughput. This might be latency. But an architectural fitness function, you define one for all of the architectural characteristics that are critical to the success of your system. And if they're that critical, they're the ones that are going to guide the architectural decisions that you make. If you don't care about performance, don't spend that cost trade-off for something that might affect performance. Spend your time thinking about the things that matter to you. The single most important feature of a fitness function is that you and I will never disagree about what the value is, which is why maintainable is not a good fitness function. Cyclomatic complexity below 10, that works great. Adherence to a naming standard, fine. Adherence to a layered architecture. All of those things are unambiguous. You and I could have a discussion about what constitutes maintainable. We can't have a discussion about the others. Incremental change. We're talking a lot about incremental change. There are two aspects to incremental change we need to think about. One is at the application layer. How do we introduce the change in the behavior to the system? And then operational change. How do we introduce that change into our running systems, and what does it do for our observability, for our performance characteristics, for our operability? And then across multiple dimensions. Here's another source for ilities, a Wikipedia page. One of the interesting things about these ilities, people will tell you, maximize them all. You can't. Many of them are mutually exclusive. That's why you need to go down this list and decide which ones are important in your context. And we're adding one, which is evolvability. But just like all the others, you might decide, actually, I don't care about evolvability. I listened to a great talk once from somebody from the Jet Propulsion Laboratory, and they were talking about a system, a cloud system they had used to analyze this massive data set that was shipped back from, I believe it was Mars. Evolvability didn't matter on that system. There was only one of those data sets. We don't have to ever reuse the code. I don't care about reusability. I don't care about changeability, evolvability, any of those kind of changeabilities. That one, they kind of cared about performance. They stopped worrying about cloud costs when they calculated it would end up somewhere between $27 and $35. They really didn't care which end of the spectrum they landed on. But you need to treat evolvability just like all of those other ilities and decide, is this really a throwaway? If it is, don't worry about evolvability. Chances are, if you're in an enterprise context, you're going to want to worry about this, though, because an enterprise's track record in general for throwing away a prototype is poor. So let's talk about some principles. How should you start to think about some of these architectural decisions if you want this to be evolvable? And the first thing is, when do you make a decision? You want to make the decision at the last responsible moment. It maximizes the amount of information you have. That's obvious. Of course, the difficult follow-on question is, when is that last responsible moment? And much of that is determined by the impact that decision has on those architectural characteristics you decided were important. Because if those architectural characteristics are driving how you architect, design, and code your system, you might want to make something like that about that decision earlier. But maybe you don't know enough, and so maybe what you have to do is make it reversible. If it's that key, you want to make sure you understand enough, or you actually pay the cost to make that decision reversible so that you can change your mind if you get that assumption that goes the other way. Architect and develop for evolvability. If you've decided this is important, you need to think about this both in the choices you make as a developer, and much of that does come down to code quality. For me, in general, deciding that code quality never matters is not an option. But then I've spent too much time looking at really bad code. And architecting for evolvability, this is where you want to think about, where do you draw those domain boundaries? And one of the most important tricks for getting those boundaries right is to try to understand how the people who are giving you requirements think about the domains. What are the concepts they have in their head? What are the fundamental processes they're thinking about? Because if that's the group who's going to come to you with a change, those are the Lego blocks they're going to be using in their head to develop, this is the outcome I want. The closer your boundaries correspond to their mental model, the easier it's going to be for you to communicate to them, the lower the cognitive load for those conversations, and the increased likelihood that you're going to have the right modules to move around. I personally believe part of why SOA went so horribly wrong in our first attempts is because so many of those services drew their boundaries based on implementations, not based on business concepts. We need to think about how we communicate. Pastel's law, and this is my paraphrasing of it, be very forgiving in what you receive. Asterisk, watch out for security. Don't be too forgiving, but be very careful in what you send. Because as soon as you send something, you're implicitly saying, I will be generating this information for you. And who knows who's going to rely on it. What this is trying to get at in part is this empowered, independent teams. Because I shouldn't have to change something unless you make a change that violates my assumptions, and we'll talk about this a bit more. But don't validate things if you're not going to use them, because then if somebody changes a field that you don't care about, you still have to make a change. You're still broken. If they change something that you need, yeah, you're going to have to fix it. This does not solve all the world's problems, but you can at least limit the scope. And of course, I come from ThoughtWorks. I have to talk about testability. But one of the things that we have found is that if you think about testability, you end up actually with quite a nice set of boundaries. And you're steered away from practices that make it harder to change things. Putting logic in some of these middleware tools is incredibly difficult to test. Testing PL SQL, that can be a real challenge. If you've got a test name, test this and this and this and this and this and this, oh, and that thing over there, you probably don't have a very cohesive boundary. Or if you do, you have it completely by accident, because you can't say what that thing is if that's the best you can come up with for a test name. So think about testability, and you'll end up with a better architecture. And of course, there's Conway's Law. One of the things that we've started doing is, okay, this is the system you want to have. Step one, reorganize your teams, because you're not going to get to that system unless the team structure reflects what it is that you were trying to accomplish. Now I want to talk about some techniques that we have learned over the years that support you actually doing this. And the first one should just be a symbolic link to the book Refactoring Databases. I've been involved with Agile teams a long time and heard from lots of different roles, oh, I could never do my user experience iteratively because I must have the grand vision of how everything is going to work. The one group, I think, who had a legitimate claim to this were the DBAs. Because as soon as something's in production, you have production data. And what do you have to do with that data? You have to migrate it. Migration is so easy. You copy it from point A to point B. What could possibly go wrong? We know what goes wrong. This is a conceptual approach to how you bring incremental change to changes in data formats and changes to data migration. It applies equally if you start to talk about graph databases and other NoSQL databases. The specific atoms, the specific refactorings you use are clearly different, but the technique remains the same. And it gives you a way to think about data architecture. And one of the other things that has changed since the dawn of time is data is much more architecturally important and recognized as such than it was before. It used to be the DBAs just guarded the data, and you thought about the systems. It's a whole lot more complicated than that, and thinking about data architecture as an explicit aspect of your architecture is important. This next one is a bit controversial. I'm certainly not saying that you should never use orchestration. You should always use choreography. Because just like the discussion between monoliths and microservices, there are things that can go wrong in a choreographed architecture that simply can't happen if you use orchestration, because it's the orchestrator's job to take care of it. But if you decide that evolvability is one of those characteristics that you really want to have, your ability to move pieces around is a whole lot easier if you've moved that error handling logic into the individual actors within your system or performers within your system, as opposed to relying on the orchestrator. So there are going to be systems where that's important. Not all of them, by any stretch of the imagination. But it is a way to get to evolvability. Some people will say, by the way, that evolutionary architecture, it doesn't make sense to talk about it unless you're in a microservices architecture. And I believe that's completely false. These other principles still apply, even if you're in a monolith. Contract testing. Let's go back to those independent teams. Pat and Randy and I are all developing services that rely on each other. Pat gives me his tests about what he's assuming, and I give him mine. Randy does the same. And then we ignore each other. Completely ignore each other. Randy can do whatever he wants, as long as my tests still pass. Pat's tests break. Pat and I talk, we're still ignoring Randy, because he doesn't have to know. Unless what we decide to do to fix our little issue impacts one of his tests, we can continue to work independently. Now, I agree with the answer to the previous question. Independent doesn't mean ignore the existence. But I can make whatever decisions I need to make, knowing that I'm not going to break anything having to do with Pat or Randy. And once I do, just like all of the Agile talk on, okay, you find out immediately when you need to have a conversation. That's what these contract tests are about. The next technique is continuous delivery, and you've heard about this before already in this conference. But when I first started talking about evolutionary architecture, people would come up to the stage afterwards and whisper, "Don't you think you're being professionally irresponsible to talk about evolving an architecture? It's the rock. It's the foundation. You can't change architecture. By definition, it's the stuff you don't change." I will say that if you are in a typical enterprise and have not yet adopted continuous delivery, it is probably professionally irresponsible to try to do some of these things. You can get started on it, but the thing that you want to realize is the more radical the changes are that you are trying to make, the more you have to know exactly the base that you're working on. Randy talked about the vernacular, that testing base. You need to know exactly how your systems are configured. You need to know exactly what code is running there. You need to know all of those things so that you can diagnose what goes wrong. Does that mean you have to allow code to go into production when a developer checks something in? There is absolutely nothing in the continuous delivery book that says you can't have somebody with a big green button sitting on their desk and nothing goes into production until he slaps the big green button. Just because you can flow through doesn't mean you have to. The thing is that you can. You've put all of that structure in place, not just in your development infrastructure, but in your operations infrastructure, so that you know exactly what your system looks like. And that means you can make the kinds of changes that would be Far too risky otherwise. Because what we're really trying to get to here is the ability to experiment. Customer expectations are changing too rapidly. Business model lifetimes are shrinking. We have to be able to try new ideas. No one wants to try a new idea if they think it might not work, and not only not work, but take the system down along with it. I'm glad to see somebody else saying deployment should be boring. We should be celebrating the features, not the fact that we didn't get in trouble. What we want to have is a platform for experimentation that will allow us to try out different ideas and see what our customers respond to, and build on those good ideas and roll back the ones that perhaps didn't work very well. We want to be able to experiment quickly and safely. And that's what having an evolvable architecture allows you to do. But you also need a culture of experimentation. Because if people think they're going to get fired the first time they try to run an experiment that fails, nobody's going to try anything unless they're positive it's going to work. By definition, if you know how it's going to turn out, it's not an experiment. Just because an experiment doesn't pan out doesn't mean it was a bad experiment. And the thing that you have to build into this culture of experimentation is that ability to separate things that were a good idea but just didn't pan out, or things that were actually just a bad idea. Not everybody has good ideas. So yeah, we have to be able to separate that if we're building this culture of experimentation. So I want to briefly go through what happens if you're not lucky enough to be starting from a green field. I've got one of these messy architectures. I've got a big ball of mud sitting out there. I have all of these things. Identify the characteristic you're most worried about. And I'm saying right now about the same thing that we were saying earlier. Talk to your business about what their business strategy is. If you're hearing that acquisitions are going to be a major part of our growth strategy over the next 2 years, then maybe you want to look at your integrations, and maybe you want to understand how some of these things work. But figure out where you're most worried. And then identify a target for that, start measuring it, and start improving upon it. The beauty when you start measuring is that you can at least reassure people, yes, you're investing in me making this better, but it's not ever going to get worse again. Back to the funicular. We can't fall back past this because we've got the guardrail now. Trends are in many ways more important than a single number. As long as your number is improving, that means you're going in the right direction. Sometimes you do have an absolute number you have to worry about, but keep an eye on the trends, particularly when a trend reverses, because that tells you you did something that you probably didn't want to do, or you did something you had to do and you just didn't understand the consequences of it. So watch the trends. And as soon as you start making progress, pick another set of dimensions to worry about. And definitely, if you've got this place over here that you haven't changed in years, I don't care how bad it is. The academic in me wants to care. The academic in me wants to say, we should clean up every bad piece of code on the planet. The pragmatist in me says, go back to your ivory tower. That doesn't exist. Because hopefully, by the time you do have to do something about that, you can just rip it out, throw it away, and replace it. So don't waste your time just because something's bad. You want to think about the interaction between what's bad and what you think you might need to change. But you can get it wrong. That's the problem. If we all had perfect crystal balls and we had the multiple universes and we could go make all those calculations, we wouldn't have to worry about this stuff. But that isn't our world. So we have to try to be as responsive as possible to as wide a range of the possible scenarios as we can. You need to evolve your fitness functions too, because that world is changing. Maybe you've just made an acquisition and now all of a sudden your internal systems are going to take more load than they've ever had to take before, so you've got to up their throughput. Who knows? But constantly reevaluate those fitness functions, because that fitness function, this suite of fitness functions, becomes your target architecture. It is the statement of what constitutes good in your system. And if you're not evolving it, that's no better than that big upfront design that we know is a problem as well. Thank you very much. And here is your Slido, which I thought I had put at the beginning, but obviously did not, so type fast. But thank you.
Thank you so much, Rebecca. We do have some questions coming
good.
up. Here's the highlighted one.
Yes. So have you used architecture fitness functions in a large project? Can you provide an example of one that is non-trivial? Probably the best known example of a non-trivial fitness function is something called the simian army. Netflix has a whole host of things that qualify as fitness functions. They are in the category of dynamic fitness functions because we look at them at runtime. But there are a whole host of things, and Pat is going to talk about a lot of this stuff later in his talk, if I'm not mistaken. Anything that's in a fitness function, you don't have to worry about anymore, because your tests are going to break if somebody violates it. So that's the best example of a non-trivial. That whole suite in the simian army, they are probing code and architecture in various ways. Another one that I think is clever. What happens on a zero-day exploit? Your security department gets all upset, everybody's running around, and they try to come up with a list. Here are all the things that have to be fixed for the zero-day exploit. And how often is one or two missed? Another fitness function can be something that is dropped in by the security department on the day that zero-day comes out. Trigger everybody's build, fail any build that has this version of this framework in it, and send an email to security. Job done. Now you have an explicit list of all of the places that's used, and you've got broken builds all over the place, so you know they have to be fixed. So those are a couple of examples.
I like this one a lot, of the focus on culture.
How do you install or convince the team to a culture of fostering experimentation? Do you have any techniques or approaches? The first thing is the leadership has to model that behavior. And some of that is to be able to say, I made a mistake. I was talking to an engineering manager at one point, and he said he was convinced that this architectural decision was right. And his whole team said, no, you're wrong. But he was so sure he was right. And so they went with his approach. Fortunately, they did put in that anti-corruption layer, so it wasn't that hard to change. But he was able to walk in and say, okay, guys, I was wrong. You were right. Let's switch. Modeling that ability to say, I was wrong, is the first thing, because it's the culture that is set by the leadership that decides whether or not someone who has a good idea is going to feel brave enough to come up and say, I think we ought to try this, and this is why. So that's the first thing you have to do. Then you need to make sure you have the scaffolding around, and you need to instill this hypothesis-driven thinking. This is the change I'm going to make because this is the hypothesis that I'm testing, that cart abandonment is going to go down this much or throughput is going to go up by this much. What metric are you trying to move? Because that gives you something to test. That gives you the hypothesis so that you can then make the objective determination, yes, it's working, keep going, or nope, not working. And finally, learn from the not working ones. What was the underlying assumption that led you to believe that it would work that turned out to be wrong? And make sure that that becomes explicit. Make sure that becomes part of those architectural decision records and why you decided not to do that. This is what we thought was true that wasn't. Because that's the true learning nugget. That's the thing that is important.
Let's come back to contract testing.
When talking about contract testing, did you mention that it is enough to have it, or that even having things can go very wrong? Yes, things can still go wrong. In particular, if you don't know all of the assumptions you're making about your systems. And that can very often be true when you've got complex integrations in a legacy architecture. Probably the best enterprise architect I ever worked with, she really wasn't all that technical, but she understood all of the different ways those systems behaved in ways that you wouldn't expect them to. But it was all in her head. And one of the things that we were able to start talking to her about is let's start getting those things out of your head and into a test. Because she was literally a bus factor of 1. Or, to be more cheerful, a lottery factor of 1. But if you don't know where those things lay, sure, Pat and I can be ignoring Randy, and Randy goes off and does something that we never told him we didn't want him to do because we didn't know we didn't want him to do it. So it can still go horribly wrong. They are still worth having, and you just want to continue to build up that arsenal between. I would rather have them and run across the occasional mistakes, but enable people to move forward as opposed to saying, we cannot give 100% guarantee that this is going to work, so everybody's got to collaborate on everything. That doesn't work.
Here's one about naming things.
Is the term architecture maybe antiquated? It implies something unchangeable. The architecture of a finished house can't be changed. Do we need a better term? It's amazing how ingrained in an industry terms can become. And they do often take on a life of their own. Just ask Martin Fowler about the term refactoring, or ask Bill Curtis about CMM. And they will all recount stories about how a concept that they thought was so clear got away from them. I think that ship has sailed. I also would assert that there are many aspects of a house, architectural aspects of a house, that are changeable. No, you can't move the load-bearing walls. You do have to tear the house down to do that. But there are many changes you can make within a context that still respect the structural integrity of the house. So I think we're stuck with the term. Unfortunately, it carries with it the legacy of, it's only the stuff that's too hard to change, and things of that nature.
And the last one.
Do you have any insights, rules of thumb on situations or things that point to the fact that the fitness function might need to be changed? First off, you're not seeing the behavior from your system that you thought the fitness function was preserving for you. When we first started talking about evolutionary architecture, one of the things that we talked about was these fitness functions were the guardrail for the architectural and bit rot over time as people forget why you were doing something or why you wanted this kind of layered architecture, because it really would be so much easier if I just went in and snagged that thing and violated all of those layers. So if you're starting to see things happen that you don't want to happen, that indicates that your fitness function is not doing its job. Another thing, though, that can change your fitness function are environmental changes. Regulatory compliance is a big one. If you've got a set of fitness functions around data protection from the year 2004, it's probably not adequate anymore. And more countries are enacting laws. And so thinking about how the regulatory landscape is changing, how the technology landscape is changing, will indicate to you how your business is changing. What are the expectations? Acquisitions, or a really successful marketing campaign, and all of a sudden we really did get that 10x user increase that they were saying. I really didn't think they were going to be able to pull that off. Maybe we need to bump up those fitness functions. Those are the kinds of things to look for, though.
Wonderful. Ladies and gentlemen, Rebecca Parsons, thank you very much.
Thank you very much.